So here we'll discuss the meaning of statistical significance. Suppose we want to prove that the average height of all US women, so we can call it mu because we're talking about the population mean here, since we're talking about all US women and the average of all women is mu, the population mean. The population here is all US women, is less than 66 inches. So what we're trying to prove is the average height of all US women is less than 66 inches. So what we're trying to prove is called the alternative hypothesis, and it is written exactly the way I've written here. Uppercase H, A for alternative, colon, mu, it's always about mu, is less than, so the population mean is less than 66 inches. This is exactly what we're trying to prove. So this is written in a very specific format that is used in logic. Now, the fact that we're trying to prove that it is less than 66 inches is, we can assume that the null hypothesis is mu equal to 66 inches. So let's just say someone believes that it's 66 inches, the mean height. We are trying to prove that it is less than 66 inches, something very specific, less than. So the first statement, what is believed to be true, is called the null hypothesis, HO, and HA is the alternative hypothesis, mu less than 66 inches. So how do you prove something like this? So we're going to take the entire US population, extract a sample from it, a sample from the population. So we have a sample of women. We're going to next find X bar, which is the average height in this case of all women in that sample. And that's the reason why we are using the notation X bar and not mu, because mu is the population mean. So now let's look at two scenarios. So let's look at the first scenario, where let's just say we did everything right. We selected a random sample using the right procedures without any bias, and the average that we get from the sample is, and I'm exaggerating here, is let's say 60 inches. Okay, it's way less than 66 inches. We'll look at a second scenario. X bar equals, let's say, 65.73 inches. So we're looking at, let's just say, the second example first, the second scenario first. Suppose X bar is 65.73 inches. And what everyone believes is that the average height of all American women is 66 inches. Now here, can we say just because it is slightly less than 66, can we conclude that there is a difference in what is believed to be true and what is for real? So our sample shows a number slightly less. But if you think about it, this can happen only because of different samples that are extracted from the population, and because of the variation that comes from one sample to another, it is possible that we have a number slightly less than what's believed to be true. So the difference between these two numbers in statistics, we say, is not statistically significant. And here I'm doing this very informally. There are very formal procedures that we use to prove that it is not statistically significant. But here I'm just using a kind of an intuitive idea to kind of explain statistical significance. So here it's not statistically significant. Because it seems like they're almost the same number with a slight variation. Now let's look here, the first scenario. Let's just say everyone believes that mu, the population mean, is 66 inches. and I exaggerated here. 60 inches is just about 5 feet tall, which is kind of impossible. But let's just say we picked this a random sample, we did everything right, and we found the average of the sample, and it's 60 inches. Now that is way, way less than what is believed to be true, which is 66. If it is true that mu is equal to 66, what is the chance that the sample that we pick will have an average of 60 inches, the average of 5 feet tall? What is the chance of that happening? The chance of that happening is so small that we can say this probably didn't happen by chance. So then we go back and question this statement. We say that we picked the sample correctly, we did it randomly. The chance of getting a sample that has an average height of 60 inches is so small that it could not have happened by chance, which means this number doesn't seem right. So then this, and of course I've done this very informally here. There are formal ways of figuring out whether it's statistically significant or not, but here the difference is so vast that we say that the result is statistically significant. Okay, so the difference between the what is believed to be true is the mean, and the sample mean is so different that it could have not just happened by chance. It would have happened only if something is wrong with this statement, which means we have proof to show, we have evidence to show that mu is indeed less than 66. It seems like we have evidence, but again, as I said, this is very informal. We're going to use some formal procedures to prove that a result is statistically significant.